Hello, mentor. If you don't know much about graph theory, then this is the video for you. So we'll explore many concepts that are important for our meeting 4 in the context, of course, of the career fields. So what is a graph? Well, a graph is a mathematical structure made out of nodes. We also call them points, and also not only the nodes, but the edges. So let me illustrate what is a node and what is an edge, which we also call connection or line. This particular graph has 16 different nodes, and each node could be anything really in the world. So these nodes here are career fields. And then between some of the nodes, we find lines or connection. The word line, it's not really much geometrically, so we don't really measure the length of this line, but it's just any line. It could be curved or not, and it just tells us that two given nodes are neighbors. So that's what it means to be a neighbor, that you have a direct connection between the nodes. For example, arts and construction are neighbors in this graph because that's how we indicate it. But agriculture and construction are not neighbors. There's no line. Health sciences and engineering are also two neighbors. And notice that agriculture and business, you would think that they're very far away or not even neighbors at all, but actually they're very close in this graph because there is a line or an edge that connects them both. What is a path between two nodes? So a path is going to be a sequence of some nodes, of some edges that connect to 2 points or 2 nodes in the graph. So every edge, it's a path. It's a particular case of a path, but there's many paths that are composed of more than one edge. For example, let's take information technology here and education, and let's try to answer some questions. Are these neighbors? They're not neighbors, but is there a path connecting these two nodes? And there actually is. If I go, for example, through engineering, then take science and math, and then take education, I can find a path between these two nodes. Is it the only path that exists? Probably not. I could go through manufacturing, then go engineering, science and math, and education. But it seems that all the paths have to go through science and math to connect these two nodes. Take another example, business and agriculture. Are these two neighbors? Yes. Is there a path? Of course. This is just path of just one edge. Is it the unique path, the only path? Not, because we could take also this path, for example, going through here. So there's more than one path connecting these two. What's the length of a path? So the length of a path between two nodes is just the number of edges that it took me to travel there. So first, let's do a more basic even example between engineering and engineering itself. So are these two neighbors? Well, they're the same, really, the same. So I wouldn't say they're neighbors because there's not an edge between them. But you could say that there's a path of length 0 because it just takes me 0 nodes to get to there. So that the length of this path, it would just be the empty path. It's 0. Other interesting example. Let's take arts and engineering. Let's take this path that goes through media, and then IT, and then engineering. And let's find the length of this path. It's just like a board game where you're moving pieces, how many jumps you need. 1, 2, and 3. So the length of this path is 3. Does it mean that the distance between these two nodes is 3? Let's take a look. So first, let's learn about the concept of shortest path. So any given two nodes, a shortest path would be a path that you cannot beat in the sense that it's already too short. So it's a path that's so short that there's no shorter path. So between arts and engineering, we have a path of length 3, but we also have a path of length 2. So this would be a minimal path or a shortest path between these two nodes. Another example, let's take, for example, tourism here and social sciences. And so you'll see that even though there's two paths connecting them, 1, 2, 3, and 1, 2, this would be the best path. Sometimes there's more than one shortest path because they both tie in the terms of distance. But here it's unique. That'd be another path. So the distance between two nodes, now we're ready to define it. It's just the length of a shortest path connecting these two. So we could say that art and engineering are at distance 2. That would be the distance. So they're not as far, they're kind of close. And then we could say also that tourism and social sciences have a distance of 3. Another example, information technology and manufacturing. Since they're neighbors, then the shortest path is just this edge connecting it. So it's an edge that in particular, it's a path. And the distance is 1. So whenever the distance is 1, it's another way to say that you are neighbors, that you are as close as possible without being equal. Okay. And again, trivial case, health with health, the distance between health and health. In case a student pick health and another student pick health, you could say that the distance is 0 because there's nothing to do. There's no energy or cost. You don't need to do anything to go from one to another. So the distance must be 0. So that's pretty much what we are needing for this video. But you could also define other things, and I'll leave it as as an exercise. What could be a center of a graph? How would you define a center? And then, the diameter of a circle, right? It's twice the radius, or the diameter in a square could be the length of the diagonal. So it's some distance. What could be the diameter of a graph? For example, you could try solving that problem. What's the diameter of this graph? Final important note, you don't really use rulers because this is not geometry to measure distances. So both this edge and this big edge here, of course, one is much bigger, but from the point of view of graph theory, they're both connecting two things and they're both count as 1 when measuring distances. Okay, so have a lot of fun in the meeting. Goodbye.